This video will discuss histograms. Histograms are used to show quantitative data that can be placed in intervals. These intervals are called classes, and each class is represented with a bar. Because these are intervals, we need to calculate the width of each interval. And the way a histogram works is it wants a value to fall inside of that interval. Histograms can measure either discrete or continuous data. Because the graph is on intervals, there are no gaps in this histogram. Let's look at this example. The data set lists the prices in dollars of 30 GPS navigators. Construct a frequency distribution table. And for this table, we want to have 7 classes. So when we talk about a histogram, we're going to make these tables. Here's what a histogram table or frequency table will look like. Notice the top categories are the class, midpoint, frequency, and relative frequency. The following steps will show you how to calculate each one of these values and fill in this table. The first step in creating a histogram is to find the number of classes needed. Generally speaking, the number of classes will be given to you. If they aren't given to you, one of the methods we can use is to take the square root of the number of observations. Remember, the number of observations is equal to n. In our case, for the GPS example, n was equal to 30. If we take the square root of 30, we get 5 point something. We always round that number, whatever it is, up to the nearest whole number. So we're going to get 6 classes that we need. But because our example wants us to do 7 classes, we will already include 7 classes. Remember, a class, we call them K, is equal to the number of bars your histogram wants to show. Once we have the number of classes we need, we're going to have to find the class width. In order to find the class width, we need to order the data. I've created a video on how to order the data with a TI-84 calculator. If you haven't watched that video, you might want to check it out now. Once you have your classes, or once you have your data ordered, you can actually find the width of the class. The width is an interval measurement. So here's how we find the width. The first step is to look at the range of the data. Remember, the range is equal to the maximum minus the minimum value. In our case, our maximum is 340 and our minimum value is 65. This gives us a range of 275. To find the width W, the width is equal to the range, which is 275, divided by the number of classes, K. If we divide 275 divided by 7, we get 39.3. No matter what this number is when you calculate, you're always going to round this number up. So we always round this number up to the nearest whole number. In this case, we're going to round up to 40. So the width of each class, or the interval distance between each class, will be 40. Once we have the class width, we can find the lower and upper bounds of each class. The bounds are going to identify which observations fall into each class. We generally are going to include the lower bound and exclude the upper bound. Algebraically, this means this. Lower bound, x is greater than or equal to the lower bound, but it's less than the upper bound. And to do this process, you're going to start with the minimum value. So our minimum value was 65. So we're going to do, first class is from 65 equal to x, which is less than, and then we're going to add the length or the width W. So we're going to add 40 to 65, those are width, and we get our first class to be 105. Now, notice that this says we include the lower bound, so we're going to include this value right here, the lower bound, but we're going to exclude the upper bound. And what happens is you bring the upper bound down to the next class. So the upper bound becomes the lower bound of the next class. So we go 105 less than or equal to x, and we're going to add the width again, which was 40, and we get 145. So let's go and fill out the frequency table with these values for the class lower bound and upper bounds. So notice here you have 1, 2, 3, 4, 5, 6, 7 rows, one for each class. In the first class, we'll set the lower bound to the minimum value for 65. Then we'll add the width, which was 40, to that class to get to the upper bound. So we get 65 less than or equal to x, which is less than 105. Now, bring the upper bound from the class above it to the next class below it. So we'll have 105 less than or equal to x, and then add the width again, which is 40. And we get 145. Do the same process, bring the upper bound to the next class. So this will be 145 up into 185. Next class would be 185 up to 225. Then 225 up to 265. Then last class is 305 up to 345. Notice that your last class, the upper bound here is 345. That means any value that you have in your data set should be lower than this class. Notice that the largest value in our data set is 340, which means that it will fall inside of our highest class. If you do not round up on this number and you use that exact number, what ends up happening is when you get to your very last class, that upper bound will actually be this number right here. That presents a problem because remember, the upper bound is never included into a class. So what would happen is you'd have to create an additional class, which would give you 8 instead of 7 classes. Once we have determined our classes, we need to go and find the midpoints. We find the midpoints because it makes labeling the histogram a lot easier. In order to find the midpoint is the average of the lower class and the upper bound, the lower bound and the upper bound. So what that means is we're going to add the two. So we'll take the lower bound plus the upper bound and divide by 2. So in our first class, that would be 65 plus 105 divided by 2. If we take 65 and plus 105, we get 170 divided by 2, which is 85. That makes 85 the midpoint of that class. So we know that the midpoint of the first class is 85. The next midpoint would be 105 plus 145 divided by 2. That's equal to 250 divided by 2, which is 125. If you notice the midpoint, if you add 85 plus the width of the interval, which is 40, you're going to get this 125. And because these are midpoints and the interval is the exact same between every class, the midpoints are separated exactly the same distance from each other. So we can add 40 to every midpoint to complete this midpoint table. So we get 165, 205, 245, 285, and finally 40 more is 325. We're going to use the midpoints to label our histogram when we go to graph it. The next step is to determine the frequency and relative frequency of each class. Remember, frequency is how often something occurs, and relative frequency is how often something occurs with respect to the total. To determine the frequency of each class, we look at the lower and upper bounds and determine if that observation fits in the class or not. So when we look at our observations, Notice that the first class is from 65 to 105. So any number falling inside it that is 65 or greater, but less than 105, which is essentially 104, will go in this class. So how many values do we have falling inside of that class? We have 65, 80, 85, 90, 90, 100, all falling in that class. So how many values is that? That's 1, 2, 3, 4, 5, 6 values. 4, 5, 6 values. Yeah, 6 values. So your frequency for this class is 6. In the next class, how many observations are greater than 105 now, but less than 145? 1, 2, 3, 4, 5, 6, 7, 8. In the next class, how many observations are greater than 145 but less than 180? 1, 2, 3, 4, 5, 6. Next class would be greater than 185 but less than 225. 5. 5 of those observations fall like that. Next class is how many observations are between 225 and 265? 1, 2. Between 265 and 305? 1. And greater than 305 but less than 345 are 2. If you add up all these observations, 6 and 8 is 14, plus 6 more is 20, 5 more is 25, 27, 28, and then 2 more is 30. They should add up to the entire total. Now, to calculate the relative frequency, we'll just take each frequency and divide it by its total. So we have 6 divided by 30, 8 divided by 30, 6 divided by 30, 5 divided by 30, 2 divided by 30, 1 divided by 30, and 2 divided by 30. We can convert these to decimals or to percentages. Once we convert these to percentages, notice what the sum of their total is. When you add them up, you get a value of 1 or 100%. This completes our frequency table and will allow us to graph a histogram.